Now, thank you very much for your presentation. There are some questions we have to from the audience, starting with an interesting approach. How did you deal with the fact that surface relative humidity and temperatures differ from room humidity and temperature, or did you also record surface condition? And then there was also an additional remark: isn't the adjusted critical RH level based on relative humidity on the fact that 50% relative humidity in room air can easily exceed 8% near cold surface? By example, exterior walls, windows, thermal pitches. For the same absolute humidity, different surface temps lead to different localized conditions where mold growth actually occurs. What are your thoughts about these comments?
Yes, I agree with that. So that's kind of, I suppose, what I was trying to say in the summary slide, that the 80% is more likely to occur on surfaces. It's unlikely to be sustainable in the air. So lowering the critical relative humidity level within our model allowed that adaptation to be able to identify mold from the air readings rather than the surface readings from the original model. So the idea, I suppose, was not necessarily to show that reduction is needed. It was more to investigate that model to see, can it be adapted so that it does work within these noisy air conditions in kind of a real world setting.
Okay, thank you. And yeah, also more in line, do you see ways to improve the model further?
We had various future plans. Unfortunately, the project's now come to an end, but we're hoping to extend it further, potentially next year. There were kind of two immediate further steps, I suppose, to also compare the results with an isopleth model, which takes the contours of relative humidity and temperature, and then identifies mold growth within those contours. So take the same approach with one of those kinds of models. And also another way that we wanted to adapt the model is to use it to apply smart control, so to dynamically adapt the relative humidity and temperature input, so to control the model's output so that it doesn't go above the relative humidity, so it doesn't predict mold growth, if that makes sense. So to dynamically adapt the model. So those are two immediate next steps that we would like to do when the project continues.
Okay, thanks very much. Mold is often most prevalent in the bathrooms. What was your thinking on when selecting bedrooms and living space as your focus area?
So yes, it is quite more prevalent in bathrooms, being a humid area. The sensors were placed for a large range of research questions across the whole of the SmartLine project. So the decision about where the sensors were placed were related to those people's questions as well, other researcher questions. So the air quality sensor, for example, was placed in the living room. And I think it was the bathroom was deliberately avoided because it has these spikes in relative humidity, so it doesn't necessarily capture the humidity more generally within the home. Yeah.
Okay, thank you for this very interesting presentation. I'd like to understand if you also asked the residents the seasonality of mold growth. In any case, how do you capture that with your model? Also, large-scale testing programs show that there is a disconnect between air and surface indicator. By example, airborne mold can be rather elevated in homes when there is no visible mold yet, or it is hidden so cannot be seen. How do you deal with these issues?
So the seasonality, we only had one time point of the question being asked. So it was only at that point in time. The surveys were typically conducted in kind of late 2017. So it would be autumn, winter time. Within the model, we use a full year of data, so we captured kind of the whole changes in relative humidity and temperature across the full set of seasons. We did also use a subset of the data, just from 1 month of data, just to see did we get similar findings, and we had similar findings from that. So we weren't taking into account the seasonality, but the mould index itself would be taking into throughout over time would be taking into account changes in temperature and relative humidity from moment to moment. Because we only had one time point for the survey question, we condensed the mould index across the whole year into just the mean average across the whole year. So we had a single time point to compare with the survey response question.
Okay, thank you. How do you assess moldy odor by smelling? And if it's smelling, how do you minimize confirmation bias?
So this question was developed by one of my co-authors, Richard Sharp, who had used it previously in surveys relating to mould, and he found that people did, and I can't remember his methods behind this because he was the one doing the research, but he did find that it was quite a good indicator of mould presence in the home, asking that question rather about visible mould, which also relates to the previous question about visible versus mould spores in the air that are not visible. So that's why we asked both these questions about visible mould, which is, it is a concrete question that you can answer, but also a mouldy odour. That would be potentially a subjective answer from the occupant. But yes, it's about the smell. Do they feel they have a musty or moldy smell in their home?
Okay, thank you. I really like the idea of using resident surveys as a data point, but we found it tricky as people were reticent to report mold in some cases. By example, I don't have mold because I clean it regularly or didn't notice it in others. Do you have general reflection about how to treat this data? Anything you do differently if you do it again?
There may well be bias in responses where people are reluctant to say that they do have mold. I'm not sure that there's kind of, as with all surveys, you can't kind of push people to answer one way or the other. We did the survey face-to-face, which with previous studies has been found to give more kind of direct and reliable answers than doing, for example, online surveys or telephone surveys. So we can only work, unfortunately, with the data that we have and trust the occupant responses.
Yeah, mold spores need to be around to start growing under favorable conditions. Did you consider to include the PM2.5 measurement in the measurement?
That's a good question. We did record PM2.5, so it is something we could look at. We haven't, but I think it would be an interesting question to look at between the relationship between the survey responses and/or the mold model and the PM2.5 levels. Thanks.
Yeah. How did you address the uncertainty local sensor measurement when defining your model?
So these sensors, I don't have the data to hand. I do have kind of accuracy ratings about them, which are, I think, in the supplementary materials of the paper, but I could look those up. It was actually at a stage when the low cost, kind of the lower cost sensors that are typically available, more widespread in recent times, they weren't so widely available. So this was in 2017, and I wasn't involved in the procurement process, but I understand that they were procured as the kind of most reliable sensors that we could get at that time within the project budget.
Yes.
So yeah, I don't know if any standardization for the sensors was done before they were introduced into the homes.
Thank you. I'm wondering if any surface temperatures has been evaluated or measured alongside to assess the risk of mold grow.
We haven't incorporated the outdoor, because we did have outdoor sensors outside some of the homes, measuring relative humidity and temperature and air quality. Kind of one analysis that I did do was looking at the relationship between the outdoor and indoor relative humidity, and we found that relationship correlated with occupant responses about how frequently they opened their windows. So that was the kind of, we could see from that the outdoor and the indoor were influencing each other, but we haven't included that information into the mold model.
And same question about the surface temperatures. Did you have maybe in some houses a look at that?
No, we didn't, unfortunately. We just had the air measurements. Yeah.
Yeah, and more in depth about health to consider, could it be that health-wise the decline period in mold growth is even more important than the growing period, because decline molds tend to produce more spores and degeneration fragments?
Okay, yeah, that's an interesting point. So again, my collaborator Richard Sharp worked with somebody looking at the air quality measures in the homes and asthma rates. So I imagine that would have also touched on the mold spores. Not that we were measuring mold spores, but the PM2.5 levels in the home, as somebody indicated earlier, might reflect that.
Okay, that can be interesting to look at.